Welcome to the Real Python Podcast. This is episode 206. How do you start adding unit tests to your Python code? Can the built-in unit test framework cover most or all of your needs? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. We dig into a recent tutorial by Leodanis Pozo Ramos about writing unit tests by using Python's unit test framework. The tutorial covers organizing your tests, exploring assert methods, creating test fixtures, and debugging failing tests. We explore a collection of Python data visualizations and tutorials from the Python Graph Gallery. The website features hundreds of charts and graphs built using popular plotting libraries. Each chart type features a foundational tutorial that introduces the structure and application. We also share several other articles and projects from the Python community, including a news roundup, the new REPL coming in Python 3.13, a Pytest Daemon to 10x test iteration speed, a discussion about software friction, a Raspberry Pi document scanner, and a project for controlling time per iteration loop. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
All right, so we have our typical lineup this week, a few news items, handful of articles, a discussion, and some fun projects for people to try out. You ready to dig in?
Yeah, sure. The two pieces of news are both from the Python Software Foundation. First up, there are 3 seats coming available on the PSF Board of Directors. Nominations open up on Tuesday, June the 11th and run until the 25th. And voting starts on July 2nd and runs till July 16th. So if you're interested or you know somebody you think should be nominated, you've got some time to get that happening. And if you want to know a little bit more about the board or the PSF itself, a good way to do that is through the PSF Annual Impact Report, which is my second bit of news. The 2023 version has just been released. The report covers highlights from the foundation in 2023, financial reporting, info on what's intended in 2024, and we'll link to the report and instructions on how to run for the board in the show notes.
All right. So my first one is a Real Python one, and it's from our friend Leodanis Pozo Ramos. It's about using Python's unit test, and subtitle is Writing Unit Tests for Your Code. It is a deep dive into everything you can think of here, which is great. If you don't have a background in testing, a little bit of suggestions here for using unit tests. You should have some background in object-oriented programming as far as how this framework works, a little bit about inheritance, and definitely lots of assertions going on. It may help if you have a little bit of background in testing, even maybe using doc test, for example. Otherwise, this article is very comprehensive, goes through all sorts of different layers of what you can do and sort of expect as you work with it. It starts with organizing your tests using the test case class, and he takes you through setting up a test for a particular function. In this one, it's one that categorizes ages, and so that's his example there, creating a subclass for test case, and then using the assert equal, and then kind of using different input values with how they would correspond to different results. He shows you how to create a test not only for equals very specific values, but also how to create tests that would cover the edge cases or boundary cases. You know, what, in this case, this age classification thing, there's a cutoff between age 9 and 10. And so he has a couple examples of showing like, well, how you could test for both of those. He covers the pros and cons of this idea of having lots and lots of assertions. Going beyond that, giving you kind of this background, he also dives into how to run the tests, properly setting them up, and then running them in the command line and the types of flags you would use for like verbosity and things like that. I really liked how detailed it is in the article, not only showing you creating these tests and running them, but again, with the expected output, either simplified or very verbose. His next section is on how to skip tests. The framework has a set of decorators for that. At unittest.skip, there's a at unittest skip if you want to make sure it's running a particular version of Python or higher. Maybe it's not on the right platform, like, skip if this is for Windows or something like that. You can kind of do some of that stuff and gives you examples of how that might look and run in there. Then he digs into unit tests, subtests. There's an exploration into the available different assert methods. There's lots of them. So everything from, again, assert that something's equal, assert something's true or false. There's the identity stuff, assert is not, is none, is not none. And then membership tests. So like you're checking to see if something's within some type of collection, like assert in a dictionary or assert as an instance of something. Then there are testing to make sure that your exceptions are running correctly, assert that it raises. There's also kind of an advanced one, assert raises regex. A couple things for warnings and how you can create a custom assert method. This is about the halfway point of this very, very detailed thing. So I'll kind of just gloss over some of the rest of it, but it's a powerful library for testing that's built into Python. He covers from then on grouping tests and creating a test suite class. There's test fixtures. So the idea of having your test have a setup phase and a sort of a tear down phase, and making sure that there's the proper data or collections that you need to be testing inside of that to make sure that that's set up, even, standing up a database or something like that. Tips on debugging tests that are failing, and then some details on mocking. So there's a bunch of reasons why you may want to learn unit tests. The most popular thing that you hear in the Python community is about a library called Pytest. In fact, we might talk about it a little bit later. But unit tests, again, there are great reasons for using it. You don't need to add any additional library to what you're working on. It comes with Python. It's built into the library. It's very well documented and integrated into a lot of the IDEs because it's, again, part of the language, which is nice. And it's the default testing framework for lots of different projects, like one of the ones we talk about a lot, which is Django. It definitely builds from unit tests, which is nice. And it features a shiny new quiz to go along with tutorials so you can test yourself about the knowledge you've learned about testing your code. Thanks, Leodanis.
The unit test help file on the web for Python has one of my favorite little bits of Python in it, which is a link at the top, which says, if you are already familiar with the basic concepts of testing, you might want to skip to the list of assert methods. So they kind of know that the reason you're going to this page is actually for this table that's buried about a third of the way down.
There's a lot of them, yeah.
There's a quick link at the top basically saying, hey, yeah, and if you're here just to look up which one of these is and how it's spelled, I find the assertion methods are frustrating because they're older, and so they don't use snake case. And so there's always that, how is it, where, and is there a space in this? Isn't there a space in this? How am I supposed to do this? Where, right?
Yeah, they're all sort of camel or whatever the case is.
Yeah, they're that sort of mixed camel case kind of thing going on. If you're interested in test articles as well, the gentleman at PyCoder has been writing a series. He's now up to part 5, I think. And he also covers unit tests as well as sort of the bigger picture pieces as well. I'm planning on linking to his latest post in the next PyCoders, which will have been the previous PyCoders by the time this is posted. I'm from the future, however that works. And he gets into things like the difference between unit and integration, and the fact that, there's people out there that say this is that and it's not this. And he's like, yeah, except then you can always find someone else who contradicts that. So he's got a great, beyond just the libraries, but also sort of the concepts of testing and how to think about it. And of course, because it's a Python site, all the examples are in Python. So yeah, we'll link to that one as well. So
okay, great. So what's your first one here?
I've got a combo, and it starts out kind of from the fact that Python 3.13 has just gone into its first beta release. The beta is where feature lockdown starts. So to go along with it is sort of a mostly finalized version of the official What's New in Python 3.13 doc. Between now and the release in October, I'm sure you're going to see plenty of articles, but here, so you can hear it here first, a quick set of summaries. An experimental JIT compiler has been added, which will be off by default, hence experimental. There are a few new additions to the typing system, a experimental support for removing the GIL. Apple iOS has officially been added as a platform, and Android is in the works. Unclear as to whether that'll be a 3.13 thing or not. I'm not 100% sure. A bunch of the remaining 19 dead batteries that were scheduled to be removed have been removed. And then the last one, which I'm going to spend a little more time talking about, is a bunch of new features have been added to the REPL. And that leads me to the second part of my combo, which is Trey Hunter's article, The New REPL in Python 3.13, where Trey gives an overview of all those features that are included. For those of you who use alternate REPLs like IPython or PTPython or one of those, a lot of this is going to seem like, so what? For folks like myself who just never got around to switching, a lot of the features are very IPython, BPython-like, and they're now going to be in the default REPL, which is a big win for those of us who don't install the alternatives. So, for example, colorization has been added for those terminals that support it, making it clearer what's prompt and what's code. If you ever typed exit in the REPL only to get a message telling you you were bad and you should type Control D instead,
Right.
if that caused you to scratch your head and wonder if they knew what you meant, why couldn't they just do it? Well, in 3.13, it just will. It will exit. And the big one, which I think is going to make a big difference for me personally, is block level history. So in the current REPL, you can only go back line by line. If you want to make an edit or something like that, that can be quite painful if you've made a mistake like halfway between a for loop. Now it will allow you to do this at the block level, and that's a big win. This feature is in several of the alternatives. So like I said, so what? But for those of us who aren't, if you were in the eventually I'll install an alternate, well, maybe now you don't have to. Quick note is that the changes are based on the curses library, and curses has not yet been ported to Windows. And so it's up in the air as to whether or not this is going to make it into the release for the Windows version of the REPL. There is some discussion about how they're going to do this, but no promises have been made yet. There's even a rumor somebody might actually try to properly port the curses library to Windows so that they could do it, and then you get 2 wins, but that's still a rumor.
Curses is good on Linux, Mac, and so forth. So it could work for the subsystem.
Yeah, it should work on the subsystem. I believe it's based on the ANSI terminal sequences. So like anything that's, the old VT100 and forward stuff should work.
Yeah.
But the little DOS box that Windows, what do they call it? The command prompt, the little bit of history built into the middle of your operating system doesn't support it properly.
Okay.
There are libraries out there for trying to get curses-like things working in Windows. In fact, we've come across a couple of them in some of our courses, but they're not part of the standard the way curses is.
All right. Well, excited to check it out. And of course, RealPython's going to be covering 3.13 in more detail. So if any of those things piqued your interest, I'm sure there are going to be several articles rounding out the summer into the fall by Gerarna and maybe a few guests again this year, along with our annual podcast episode and video course. So my next one came across as a singular article that was called Best Python Chart Examples. And I decided to dig deeper beyond just these sort of chart examples and look at the underlying site. The underlying site is called the Python Graph Gallery, and it's managed by it says this website is a work of Jan Holtz. And Jan is a big fan of data visualizations and has been gathering all of these different examples of graphs and charts and these hundreds of these things. And these are all ones made with Python and use a variety of the libraries that we've talked about on the show, things like matplotlib, Seaborn, and so forth. And what's cool is each of the examples has corresponding reproducible code along with sort of deep explanations what's happening. So if you're interested in getting into data visualizations or you want examples that you can kind of take and jump off of, this is a really great site. Most of the examples are not the super vanilla types of stuff. They're much more advanced and have very pretty examples, stuff that you would see on very fancy websites, things like the New York Times or other places like that. And then also things that you might have seen in print. I'm very impressed by them. They also have a set of tutorials to get beginners started, and they work from the basics up to the very advanced data visualizations. I mentioned a couple of the libraries, but matplotlib is one very heavily covered. Seaborn, the matplotlib types of features that are built into pandas already. Plotly, which I've mentioned a few times in here, which is a nice hosting platform, along with the features of charts and graphs inside of it. And then Plot9 that I've mentioned a couple times. I want to mention two, just briefly, that I grabbed my attention and I thought were really kind of interesting and I don't see covered very often. The first one was animation being done in matplotlib using something called Func animation. This one has an animation with text that highlights these important events as this stacked area chart kind of moves along. It also has persistent text in underscores, like these sort of pivotal moments with these lollipop little things appearing. The plot is an animation that displays the evolution of objects launched into outer space by the USA and Russia between 1958 and 2023. There's something I've mentioned a couple times on the show as a data, kind of like a data meetup type of thing. It's called Tidy Tuesday, and I'll try to provide a link for that also, but that's a common thing between the R and Python communities. So this was one of the ones that was made for a Tidy Tuesday challenge. Lots of steps. It's very detailed. I think it's a really effective way of sharing this information. It uses pandas, NumPy, and then a little bit of Pillow for this thing called image sequence. And then again, uses the Func animation thing that's part of matplotlib.animation. The other one that I thought was really interesting is a Sankey diagram, which I'm not that familiar with, but when I saw it right away, I was like, oh, this is a really interesting way to show information. I think these are really cool, but I feel like they could get really noisy depending on how much information. And I guess that's true of any chart or graph or data visualization. You have to be really careful how you want to do that. I added a link that you can check out for sankey-diagrams.com, which has lots of examples. Doesn't look like it's been updated a lot since 2021, but I grabbed a couple of definitions they gathered on the site. The first is that sort of a subheading, a Sankey diagram says more than 1,000 pie charts. The Wikipedia definition of it is a Sankey diagrams are a specific type of flow diagram in which the width of arrows shown proportionally to the flow quantity. They are typically used to visualize energy or material transfers between processes. And then from the chemical engineering blog, a Sankey diagram is a directional flow chart where the width of the streams is proportional to the quantity of flow, where the flows can be combined, split, and traced through series of events and stages. So this one is a Plotly documentation. It seems like Plotly maybe has the best library for doing Sankey stuff. It has a function for that and handles lots of the business logic that you would need there. It includes a very detailed blog post linked with not only the data and describes all the customization code and so forth. This one is an energy forecast for 2050 from the Department of Energy and Climate Change. Very cool chart. Lots of neat examples there. I was just impressed by the collection. Again, if you're interested in data visualizations, want to play around with some different tutorials, the Python Graph Gallery.
And for the anal retentive, or if you're Googling this, it's Sankey. Sankey.
Yeah. Is that how you pronounce it? I'm guessing.
It sounds like there might be a D in there. It's actually named after an engineer who came up with it back in the 1880s or something like that. So,
yeah, it could be like Sankey.
Yeah,
it could be the other way you might pronounce it. Yeah, and there's a link to contribute if you create something like this on GitHub. This week, I want to shine a spotlight on another Real Python video course. Python has a lot of graphical user interface frameworks, but there is only one framework that's built into the Python standard library. And this course is titled Building a Python GUI Application with tkinter. It's based on a Real Python article by David Amos and is adapted from a chapter of our Python Basics book. In the video course, instructor Darren Jones shows you how to get started with tkinter with a Hello World application. You'll work with widgets, such as buttons and text boxes. You'll control your application layout with geometry managers and make your applications interactive by associating button clicks with Python functions. Along the way, you'll build a couple of applications, including a text editor with saving and loading functionality. I think learning how to use a GUI framework is a good investment of your time, and tkinter is lightweight and relatively painless to use compared to other frameworks. And like most of the video courses on Real Python, the course is broken into easily consumable sections, and where needed includes code examples for the techniques shown. All Real Python courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. What's your next one?
I've got a very specific case of performance improvement by Ruby Feinstein. Ruby works for Discord, which is one of the internet's most popular messaging places, and they have a Python monolith that powers their API for sending messages. The article is called Pytest Daemon, 10x local test iteration speed, and as you might guess from the title, they use Pytest to test their beast. They've been adding features to their software for almost 10 years, and in that time, their test suite has got to the point where running a single test can take about 13 seconds. This is largely due to the fact that they have a global configuration file that does a huge amount of importing, which they refer to as importing the universe. So with apologies to Carl Sagan, if you wish to make an apple pie from scratch, the first thing you must do is import the universe. So,
billions and billions.
Billions and billions. So as you can imagine, having this kind of startup time is frustrating. But beyond that, it tends to have a social effect of developers not wanting to run the tests as frequently, which of course is bad. And if it takes a while to run a test, I might go off to my email or some other distraction and lose my train of thought. So there's consequences to this besides just, hey, 13 seconds. So Ruby's solution, he really has to start going by his middle name or switch his programming language. Mr. Feinstein's solution is a daemon. What he's done is build a script that starts and does the Pytest initialization, i.e. importing the universe, then sits and does nothing. And when you need to run a test, it gets invoked by the daemon, which then hot reloads the test in question and avoids the startup cost.
All right, permanent standby.
Yeah, so there's some logic in here to handle just what has changed and what needs to be hot reloaded, but the results can't be argued with. As so much of their performance cost was in the startup, paying that once rather than each time you want to run a test was a big win for them. So an empty test that took 13 seconds the old way now takes only 0.4 seconds if you pass it off to the daemon. Running tests with complex dependencies where you've got to do some tricky reloading stuff is up to about 2 to 4 seconds, but those same tests take 17 to 20 seconds without the daemon. So overall, their median test time went from 20 seconds down to 2. So they've even written a VS Code plugin that can take advantage of the daemon. So it's a neat little solution to kind of an ugly problem, and it's a different way of thinking about things. You know, episodes back, we talked about the challenges that you have with Python because it's a dynamic language, and then we came across that article that was like, hey, yeah, but here's all these things that you can't do if it doesn't.
Right.
And other languages kind of do this, but some of that hot reloading stuff comes out of the fact that this is a dynamic interpretive language, right? So this is a feature that can be done more easily because of the so-called downside of Python. So there's some power there.
Yeah, it's actually kind of called back in my mind right as you started reading this. I forget the term for it. I don't know if it was alarm fatigue.
Yes.
But a similar kind of thing. In this case, if your code is getting in your way of your flow, if you will, yeah. It's definitely one of these things where like people are skipping it or jumping past it, or you're losing your place as you do it. It's like, what was I doing? You know, so
yeah.
I guess that might relate to our discussion then, which is kind of interesting.
It could be a point of friction. Yes. Spoiler alert.
Yeah.
So our discussion this week comes out of an article by Hillel Wayne, who we've actually mentioned twice before. In episode 141, we discussed his article on micro features Python should steal from other languages.
Yeah. And
in episode 147, we discussed an article that was in response to his article called I'm Disappointed by Dynamic Typing. And in fact, that response article was what I was just talking about. So anyhow, The discussion this week is on a new post of his, which is called Software Friction. He starts out by using a definition of friction from a military history book called On War, which he had read recently. And it states, in strategy, everything is simple, but not on that account very easy. Everything is very simple in war, but the simplest thing is difficult. These difficulties accumulate and produce a friction. So Hillel points out that ever since he read this, he's kind of seeing friction everywhere now. And in the software world, he mentions a few examples, right? That API that doesn't quite work, or it did, and then it changes, bugs that you sort of look at and go, well, why haven't they seen this? Why haven't they fixed it? Security alerts, the upgrade that breaks things, all that fun stuff we call software.
Yeah.
So friction tends to compound. And although not everyone agrees with the advice of not to release a product on Friday, this bit of wisdom derives from the fact that mistakes during deployment or rollbacks would be compounded by the fact that they might not get discovered until no one is in the office.
Right.
So the person on call probably wasn't the person that caused the problem, and hence you get a compounding friction effect. So Hillel then goes on to talk about some ways of addressing friction, including smaller scope and shorter iterations, more team autonomy, redundancy, automation, and more. So do you have a favorite example or a favorite solution? What did you think?
I wondered about this quite a bit. Like he offers some solutions that are used maybe in different fields, the idea of how in war, like how can they prepare for these types of things? And they do wargaming, the idea of practicing and being prepared for different kinds of situations. I don't know how you create weather in that sort of situation. I guess you can kind of simulate it the way they do in the movies. But I thought about security does things like pen testing, kind of prepare for different things, and maybe has an outside, I think you've even said it already, sort of red versus blue teams trying out other people's stuff. And this is stuff that you, I think, learn as a program manager. Like you would do some gaming in your studies to kind of get an idea of what some of this stuff is like and some of the challenges you might be up against. But I don't know how often that sort of a gaming, if you will, happens in the software world. It's probably pretty rare. We had like a little tiny discussion as we were getting started today about the idea of, depending on the funding of a company, they may not have the separate systems running parallel. It makes sense to only stand them up, when they need to do development of new features, to have it run in parallel for a while and then just turn it off. Whereas like, quote unquote, back in the day, they would probably have two or a third system that was like totally a testing system running at all times, even though maybe it wasn't being used at all times. So I don't know. Those are some of my thoughts. I had one example of the not deploy on Friday, but deploy before going to a week-long concert. I was working for the marketing firm I mentioned sometimes on here, and one of the people that had created this automated tool that was being used in the office, they went off to Coachella and didn't leave too much, instructions. In this case, I truly believe it was one of those where it was just running on their computer because we weren't given network tools for things that could stand alone and so forth. And so what happened? Well, I'm sure it was not on purpose, but they had to do it. It was IT ran updates and rebooted the computer and the thing didn't restart. And so our automated tool wasn't there. And so I had to kind of go in and run things. And so those sorts of things happen. But I think that's a brittle kind of breaking point. If you're going to automate lots of things, having someone there that can manually do these things and having that truly documented, I feel like definitely is an area of friction and trying to plan for that stuff. Like I know people don't like writing documentation. I don't know if that's a friction per se, not having it, or the engineer who's reluctant to do it and so forth. But I don't know. Those are some of my ideas on it. And I don't know if I have a direct question yet.
Your example reminds me, there was a very large organization I was working with that got bought by an even larger organization. And the IT in the very large organization had been a IT consulting agency that the very large organization ate.
Okay.
So they decided to continue running it internally, even though it didn't service anybody but the large organization, but they allowed them to continue to run the same way a consulting organization does. And This meant they didn't tend to be particularly responsive. They tended to over-engineer everything, and their internal pricing was often ridiculous. And this is, this causes interesting effects inside an organization. First, it impacts the rollout of things, right? So you've got this little bit of friction happening where, we don't want to talk to the IT people, or it's going to take longer or whatever. So now all of a sudden your releases are a little larger. Your releases are a little larger because you want to talk to them as frequently. Well, the other thing that it might happen is if it starts to become really, really difficult to get something out quickly, you start getting shadow IT, where folks are building and putting systems that aren't officially part of the environment. They're in boxes under your desk because they know they don't want to go through the hassle of having to deal with the internal IT people. And I remember when being subsumed into this very large organization, having several conversations with people where I'm like, well, where does that run? And they're like, under my desk. Don't tell anyone. And it was just like, it just kept happening over and over again. Oh, that's in a closet. I'm like, oh, you mean like a server closet? No, I mean like where we keep our jackets. I'm like, oh, okay. And so this is how friction compounds, right? Because now all of a sudden you've got shadow IT, and shadow IT is more likely to fall down. It's less likely to be backed up, and you've got all these kinds of things, right?
And we don't officially talk about shadow IT.
That's right. The first rule of shadow IT is we do not talk about shadow IT. Right?
Exactly.
So this is where that kind of compounding kind of thing sort of comes from. The other place where I've sort of seen this show up a lot, and it's the cause of it is outside of IT itself, which is, at least in North America, the accounting rules allow you to write off capital expenditures different than how you write off operation expenditures.
Yes.
And this is purely just an accounting mechanism. But what ends up happening is the accountants and the MBAs get together and go, oh, well, we need to shift this from being a capital cost to an operations cost, or vice versa, in order to play whatever game they are for tax purposes. And the end result of this is things like, oh, we won't buy you extra servers, even though you're spending 3 times that in person costs. And, we could save you person years worth of development by buying you another server, but we can't do that because that's an asset and we're not allowed to put money into assets, right? And this is where we lose the bigger picture of, hey, this is costing the company more money, right?
Yes.
And again, these kinds of things compound and end up affecting you because all of a sudden as you were kind of talking about at the beginning, your staging and your production environments don't match each other, which means rollouts are more expensive, which means they're higher friction, which again, compounds all of these kinds of things. You hinted a little bit there about the whole blue-red. In case folks aren't familiar with this, red teaming is a military term during gaming that is used to imply people who are going to pretend to be the enemy.
Yeah.
And so essentially both groups are given a scenario, and then they go off and they plan, and then they game against each other so that they both can get better at anticipating how other people will operate. And it's kind of a borderline example, but the idea of eating your own dog food, or the nicer phrase, which is sipping your own champagne, that companies should run their own software, is kind of sort of in that area, right? So if we're running the beta internally and we're seeing the friction, we know our customers are going to see that friction. And in theory, we should fix stuff before we roll it out, right? And it's not quite red teaming, but it's forcing your folks to sort of use the tool and be familiar with the tool, and you're more likely to sand off those edges and make things a little more frictionless.
Yeah, I feel like, again, if the loop isn't so large and you can develop software for the individuals that are going to use it and watch them use it in front of you, that fixed so much of the friction for me in development. And I really enjoy that type of environment, but that's not super common.
And it's, it's the theory behind Agile. And I want to get into the conversation about the theory versus the practice, because very little of the practice applies the theory, but the concepts behind it are more frequent releases, more interaction with your customers. And again, it all comes back to these ideas of, let's detect problems early, fix them when they're small, rather than wait until they compound.
Change the direction early, as opposed to like having to do major course correction late.
Yes. Yeah.
Okay.
Exactly.
Yeah, it's an interesting article. Lots of just sort of food for thought. The planning for redundancy is hard too, again, with how I think about how lean everything is running right now. Just trying to meet whatever Wall Street number or whatever the hell it is. It seems so I don't know. I don't know where we're headed with it. It's,
Yeah.
it's kind of a sobering, maybe / depressing thought. But I wonder if how that's going to maybe bite some people
Yeah.
by
Well,
the end of the
this
year.
actually it's a solid example of a automated version of a red team is Netflix is notorious for having something called Chaos Monkey.
Oh yeah.
And Chaos Monkey deliberately knocks things over. And this isn't just a testing framework, they run it in production. So you know that there is a chance that a random script is going to cause your application to fall over in production, not because of bugs, but because stuff happens. And as a result, they have a very defensive programming mechanism, knowing that things have to be able to detect when things fall over, knowing that they have to be able to restart quickly, knowing that you have to have this kind of redundancy. So they've kind of built this red teaming idea into their culture,
Yeah.
and it's one of the reasons they have such high uptimes.
Yeah. Well, I think that takes us into projects this week. I'll go first. I haven't talked a lot about electronics in a while, and I found this project in the PyCoders, and I was like, oh, I like that site, Instructables. I used to go there all the time. And one of the things that was featured is a Raspberry Pi document scanner. So you can think of like this overhead camera looking down at a little thing. You put your piece of paper on it and hit a button, makes a nice little beeping sound, and boom, it's scanned and ready to go, which is kind of neat. I like the idea. So it uses the Raspberry Pi 4B, the Pi Camera V2. You do some 3D printing for some components. A couple other extra things you need. You need a little SD card for the Raspberry Pi, put the operating system and all that sort of stuff on it. And then a USB stick to be able to move your scans back and forth between the Raspberry Pi and, say, your computer. It also requires a couple electronic parts, some LEDs, some resistors, a push button, and a little speaker to make the beep sound I mentioned, and jumper wires. They mentioned using a breadboard to simplify the testing before some final assembly and soldering everything together. It includes a YouTube video. If you're interested in just sort of like seeing what this thing looks like and running, you'll get an idea of what it looks like when it's fully functional. And the instructions are very, very detailed. And it's kind of fun to see the steps go a little bit beyond just the Python code, because there's a lot of like techniques, if you will, sort of Raspberry Pi DevOps kind of stuff, where you're setting up and doing the configurations, not only getting the OS image together, but configuring the Wi-Fi. You're going to do most of this in a headless type of situation. So you're remoting in and doing SSH for that. You update the Pi using the typical Linux stuff of apt update, installing Python, pip installing a few packages, and then activating the virtual environment. And then it provides the Python code, which is very detailed. And I got a little confused. I, again, was in a hurry kind of scanning through things as I started to go into this. And I'm like, this cannot be the complete code. And I missed the scroll bar. Oh, it scrolls for quite a while because there's a lot of code. In fact, most of the scanning code is using Open Computer Vision, OpenCV or OpenCV2. If you are interested in computer vision and seeing some kind of neat uses of that, it does some interesting things. There's some like initial, like little bit of blurring, and then sort of like, okay, do some edge detection, making sure that the edges of the piece of paper are aligned properly. Cool ideas. A lot of that stuff, again, explored. I feel like computer vision always kind of moves in this direction of like object detection and things like that, but it actually can do some other interesting stuff here. I thought it was a neat project. And again, if you're interested in, maybe you got a Raspberry Pi laying around and you want to check out some a new project for doing this, it's a rather complete project. And I don't know if I mentioned who did it. This is from Leodanis Workshop. Again, it's on the instructables.com. So what's your project?
I've got something called Pacemaker, and it's by Brandon Roher. What this library does is give you a consistent time for a loop to run. This shows up a lot for games when the timing of the main loop is connected to the frame rate for your display. You don't want the game to be faster just because someone has a speedy machine, so you want to be able to rate limit how it runs, and this library helps you do that. Can also be helpful for rate limiting API calls, doing real-time simulation, any kind of animation, all that kind of stuff where time is important for how long something's supposed to take to run. The library is good down to a microsecond, which means in theory, your code could run up to 1 million times per second, 1 megahertz. And the use of the library isn't particularly complicated. You import the pacemaker class, instantiate it with the timing in iterations per second, and then essentially just call the beat method inside your loop. The beat method returns the amount of time delayed. So if you're wanting to know, how far off it was, how long you had to wait, it'll tell you. And interestingly here, this isn't just a sleep call. So the pacemaker is aware of the wall clock. So it doesn't just add a naive delay. So for example, if one of your iterations takes more time than it should, like say you were supposed to be doing something once a second and your iteration took more than a second, the beat will actually shrink subsequent delays in order to get you back in sync with the wall clock. So an iteration may actually run faster than what you've asked for in pacemaker so that long-term you're in sync is the idea. So if you were thinking about from a video game point of view, one of your frames stalled, well, your next frame might get half amount of time and it might not be on screen as much, but then at least you're going to be back in sync and, the music isn't going to sound weird or whatever. So, cool little library. If you play in the real-time space at all, this one could be useful for you. A quick shout out to Brendan's in-progress self-published book titled How to Train Your Robot, which covers Python, machine learning, animations, and more. In fact, this project came out of one of the chapters which talks about timing. So we'll link to that in the show notes in case you want to check it out.
Yeah, I like the use of beat there. That definitely is makes sense to me.
Yeah, of course.
The idea of like rushing and dragging and
yeah.
and the beat continuing on or potentially the other players. And I could see that maybe with a robot, like even if something took a little long, it may stagger, but at least, as long as you keep it going. Whereas, like you said, with a typical sleep call, it's sort of out of time. It's just sort of happening on its own, which is kind of interesting that this would be much more like, keeping a pace, keeping things going. So that's a well-titled project. Well, thanks for bringing all these projects and articles this week and all the PyCoders goodness, Christopher.
Always good to be here.
All right. Talk to you soon.
Cheers.
I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.